Hi guys, welcome back to another video. My name is Yusuf and I'm an Oxford medical student. I'm also joined by our guest, Leo. Do you want to introduce yourself?
Yes, so I'm Leo. Hi, I'm a first year medical student at the University of Oxford.
Awesome. So we're going to be going through a mock interview. I'm going to be the interviewer, Leo is going to be the student. We're going to be able to go through it. The key things to think about when you're watching is what went well, what could be even better. How is he verbalizing his thoughts? Because remember, it's all about how you can think as opposed to what you know. All right. So let's get into it. Hi Leo, lovely to meet you.
Lovely to meet you too.
How are you?
Great, thank you.
How was your journey here?
It was great, thank you.
Okay, so I'm going to show you this graph here, and I want you to talk me through what you can see. All right.
Yes.
So what's going on here?
Okay, so I do not recognize the content of the graph, but I can see 12 columns in a black and white graph and bands of different width and intensity.
Mm-hmm. And what do you think it could be showing? What could those bands be?
I don't know, honestly.
You might have heard of something called DNA fingerprinting that you might have covered at school.
Yes.
Can you tell me a bit more about what's going on?
I mean, if the bits are DNA, it's certainly comprised of different DNA of different characters. I suppose it's weight or something because it's separated in different intensity and at different places.
Good, so it's separated in different intensities. And in what way is it going to be separated? In what way could it be, I don't know, filtered or sorted?
I guess it relates to the structure of DNA in this case. I'm not sure how this technique is carried out. That's why
Okay. And remind me, what is DNA?
So it's deoxyribose nucleic acid.
Yeah.
It's an acid.
Yep.
And it's a long chain polymer made of nucleotides.
Yeah. And what are the key functional groups you're going to have on DNA? You've kind of already mentioned some of them.
Yeah, so it'll be a nitrogenic base, a pentose, and a phosphate backbone. Great,
fantastic. Now, if I say that, this is done through a process called electrophoresis, so electro meaning electricity, so you're having a charge going through it. Okay. Can you talk to me about what could be going on? So what charges electrons? Not a trick question.
Negative.
Negative, okay. So if you've got this negative flow, what could be happening?
So a negative flow of electron in the gel.
Yeah. Yeah.
So I guess the DNA will be so that might be how the DNA is separated in this case. Mm-hmm. Does DNA itself carry a charge?
So what functional group could be affected in this negative electricity that we've got here?
Definitely not the pentose.
Okay.
I don't think the base is affected as well because it is bound to each other by hydrogen bonds only.
Yeah.
Must be the phosphate.
The phosphate, okay. And what is that going to be attracted towards?
A phosphate group carries two negative charge, but because there's bonds involved in the DNA, there's only one. It's a negative one charge, so it must be attracted to the positive electrode.
Good. And what's that positive electrode also known as?
The cathode?
The anode.
The
anode.
No.
Yeah, but that's fine. That's absolutely fine. So good. It'll be attracted towards that positive electrode. So then what's going to happen?
It must separate for some reason. I presume it's a charge difference. Oh, or maybe it's because different DNA fragments have different length to it, so it might move differently.
Why is it going to move differently?
So I imagine like the velocity of a larger object will move slower with the same amount of attraction or the force applied to it. So maybe the larger, but at the same time the charges will be also be larger on a longer DNA fragment.
Good. So you're thinking about the charge of it, but then you're also thinking about almost the physicality of actually moving through as well. And if I tell you it's a gel, do you think that's going to be quite easy to move through?
No, it's going to be a lot of friction.
A lot of friction. Okay, good. So what do you think that's going to mean?
I think the friction may not increase linearly according to the size, whereas the charge is going to increase linearly with the size. Because in a gel, if I think a very long thin object moving across a gel, if it's very thin, it can. I think it's the surface area that determines the friction. So a longer fragment will almost encounter the square of whatever the smaller one is.
Okay.
So maybe friction is a bigger player in this force equation.
So what do you think is going to be the slowest?
The larger fragments.
And therefore you're saying that the fastest is going to be the smallest?
Yes.
Okay, interesting. All right, we'll move on to the next one. What I'm going to show you here is something called a pedigree. Have you heard of a pedigree before?
No, I don't.
No? Okay. So what this shows you is a family history.
Right.
And just for reference, the squares are male,
Okay.
whereas the circles are female.
Okay.
Okay, so if you just want to have a look at that, and you can see that the affected ones are going to be in red. All right. So can you tell me a bit more about what's going on here?
So I can see a family tree really.
Yeah.
Linked by, so the parents are linked to the children and so forth. There's 3 generations, and some of them are affected by a certain disease, marked in red.
Yeah.
Not predominant. There's 4 female and 3 males involved affected. So not really conclusive if it's sex linked or anything.
Okay, good. And if you were to comment on the heritability of this, what do you think this could be?
Can I take a minute to think about this?
Yep.
Right, so, okay, I don't think this is X-linked.
Okay.
Because
what does X-linked mean?
So when a mutated gene is located on the X chromosome, definitely not Y-linked, by the way, because if it's Y-linked, all the males will be affected by passing down a mutated gene from their father. But it's not. I said it's not X-linked because if we look at the second row, the last male on the second row, he is not a carrier because he only has 1 copy of the X chromosome and he's not affected. If it's X dominant, all the offspring will have the disease, which is not the case because all the X chromosome is passed down by the mother who is affected. It is not X dominant. It is also not X recessive because in that case, the daughter, the last daughter on the third row will have to carry a dominant non-affected gene by the non-affected father, which is contradictory to the graph.
Okay.
It must be autosomal in this case.
Autosomal? And would you think it's autosomal dominant or autosomal recessive?
So there's another information on this. Okay, there's another piece of information that the patient marked as X has a homozygous phenotype. Okay, if she is homozygous, she must be recessive because it's autosomal, and if she is dominant, her son will have the disease, which is not the case. So yes, it must be autosomal dominant.
Autosomal dominant?
Yeah.
Okay, all right. And if we now go on to this one here, I want you to now consider some ethical challenges. Okay? And what do you think might be a problem during genetic testing for something like this?
Genetic testing is a really hot ethical issue.
Yeah.
Where because of the importance your genome is and how easily it can be used to identify individuals lacking information. So I think it's important to restrict what genetic testing you're consenting to. The patient must be aware and give an informed consent of what the genetic test is used for. And also only restricted people can have that information, namely the geneticist that is carrying on the test. But also because of the unique challenges imposed by genetic testing, which is that your family is also potentially going to be impacted by this piece of information you have, because your family is going to carry similar genes that's related to you. So that is a very interesting area in which I think at the end of the day, it is the patient's own autonomy to consent to a genetic testing procedure. If their family is affected, we should definitely have a conversation with the patient to see if they want to share that piece of information. But they are not the only ones at risk of the disease.
Yes, so what kind of things could we test for genetically? Are you aware of?
I only know we can screen a whole genome, or we can cut off certain fragments to see if there's any mutations in it.
And what kind of things are we looking for? What kind of diseases could we have a look at or screen for?
So definitely something that's inherited, something that's caused by a genetic mutation.
Any examples? Have you covered something that might be autosomal dominant before?
Yeah. I think it's Huntington's disease.
Huntington's, absolutely. It's autosomal dominant. Yeah,
Right.
absolutely. So you can screen for something Huntington's. What else could you screen for, maybe, that you might have heard about?
I don't know, but like type 1 diabetes.
Ooh, that's an interesting one. What about type 1 diabetes? Is that a completely inherited condition, do you think? Is it completely congenital?
Oh, sorry, is type 2 the congenital type of
So
diabetes?
there's always it's a complex interplay, isn't it, between genes and environment.
Okay.
For something like type 1 diabetes, you need to think about the predictive value. Yes, it's definitely genetic, and yes, it's more likely out of type 1 or type 2 to be one that you have at birth. It's very difficult to be able to screen for it in the same way that you could for something like Down syndrome, where it's much clearer when you've got a structural abnormality that you can have a look at.
That makes sense.
Does that make sense?
Yes, yes.
So what I want to pose to you now is having a look at this example. So have a quick read. I'll give you 20 seconds.
Right. Oh. Okay.
Talk to me about your approach here.
So it's definitely a very challenging situation. And I think the main thing is to consider the patient's privacy because it is a very sensitive piece of information. If I was in the position to tell her this, I would definitely ask for some time alone and establish the situation in a really sensitive way. Try to be non-judgmental and create some rapport, show her some options, what is going to happen, and really put the right to disclose this information in her hands. We don't know where this parental gene is coming from. Maybe it is because of difficult relationships. Maybe it is because of mutations. We don't know. So I am not in the place to judge in this situation.
So what do you mean by that? What are the two ways that you can get a mutation?
Two ways, I mean, as inherited and just spontaneous.
Spontaneous, fantastic. So you're questioning to the extent to which it's a spontaneous mutation, or is it something that's actually inherited?
Yes.
Okay, really good. Anything else you consider here? So you've spoken about the mum's confidentiality and how you'd want to speak to her. What would be your next steps? Would you speak to the husband?
I think that whether the husband should find out should be the mother's decision, because it is her, I mean, although I respect the husband's right to support her, really, this piece of information is totally private, and it should be her decision to make rather than a doctor's role to disclose this.
Okay. Anything else you'd want to consider? What has been diagnosed? What has been shown?
That the child has a congenital condition.
Good.
Oh yeah, so the child is actually also the one at risk and the patient we need to center stage on. Yes, so definitely I'll show her certain options that her child might take, and I think that might be a piece of information her husband is entitled to, although I may not disclose that it's a parental gene not coming from him. But the treatment options and the extent of what is going on without disclosing that this is a parental chromosome, I think that is worth sharing with the husband to see how they can support the child and what is going to happen.
Are there any other ethical implications to think about? If, for example, you find out that it is, I don't know, Huntington's, and it's coming, it's certainly not from the maternal side, but then the husband finds out that the boy has Huntington's, the husband might have a look at his own family history, and he might find out that actually he doesn't have a family history of Huntington's.
Right.
So, what are the ethical implications of disclosing the actual condition to the husband?
Yeah, so the husband may find out more about the condition, as you said, and if I do not disclose that as a paternal chromosome, just put some general information on it, he might find out himself, and that might damage his trust in the healthcare system in general, which is definitely not something I want to do.
Genetic editing has become a very prominent option for treating something like Huntington's disease. So, can you tell me a little bit about what you know about gene editing?
So I know there's a very hot technology coming out just the last couple of years called CRISPR that can locate a very specific gene, cut it out. That is a very promising technology because it can now allow us to target sorts of sequences and allow us to do phenomenal things, not only in the medical care setting that we are able to treat certain congenital diseases, but also there's a lot of application in the food industry to try to make produce that's resistant to extreme conditions and allow more production that really helps in world hunger situation.
Just because you mentioned it, what are some of the consequences that could happen about using or genetically modifying some vegetables, for example, or some food sources?
So there is a very stringent program to monitor these kind of food genetic editing technologies because they are targeting the market right now, but at the same time there are a lot we don't understand about their genome and the consequences of genetic editing. I mean, we're doing lots of trials, but there might be long-term effects that we just don't have the time to discover yet. And so I think the research needs to be very carefully monitored and be used to reevaluate our approach in genetic editing the produce as we carry on. Because the last thing we want to do is to tackle world hunger just to bring in more side effects.
Yeah, good. And in what way could, say, vegetables be genetically modified?
So, I mean, for instance, it can be edited to secrete, let's say, some sort of natural antibiotics to prevent. This is just a text.
If we're talking about foods, what about foods? How would you want to modify foods in a way that could be useful? Say, to tackle world hunger. How would you go about that?
So definitely I want the plant to be more capable of, say, taking up nutrients so that it might grow more food that we can use, but also deliver the nutrient to the right pots. Say tomatoes to be bigger, or I might want more tomatoes to be on a single stem so I can harvest more on the same area of land.
Just on what you mentioned there, more tomatoes on a single stem. Why is that also quite useful? What are you increasing there?
The efficiency of the land I'm using.
Yeah, the yield as well. Yes. So if we put area and land aside for 1 second, if you think about it actually in terms of the plant as a whole, if I tell you that some proportion of that plant could be wasted, i.e. in the stem that isn't usable,
yes,
how could you apply that to your answer?
So we can try to reduce the weight of whatever that cannot be consumed and increase the proportion that we can consume.
Fantastic.
And that might be achieved by genetic editing.
Yeah, fantastic. And you also spoke about time as well, and in terms of size as well.
Yes.
What else could be done to solve world hunger by genetic editing vegetables?
There's so much potential, but what I'm thinking is maybe we can increase the time we plant to mature from let's say. So if we can harvest twice per season, or twice per year really, rather than once, we will have double the amount of food.
Good. So again, just more on the disadvantages of doing so. You mentioned one already, particularly in terms of the side effects and maybe some sort of instability.
Yes.
What else could happen?
So if we get carried away in this genetic editing trend, and I'm just trying to think that if the side effect is out of control, we might not be able to contain the situation.
Okay, so side effects that could happen from actually eating the foods. What about the plant itself, in terms of disadvantages that could occur?
It might.
So you spoke about growth. Talk to me a bit more about that. What could be the disadvantages of it?
The stem is there for a reason naturally, and if there's less stem in terms of whole content, stem is nutrient and water translocation, and if there's not enough stem, the nutrients may not get into the place it needs to be as fast as we want, and may yield in smaller fruits than we want. So it might yield, like, edited plants might not always be the better version of what we are having right now.
Good. And what could be the disadvantages of having a plant that actually grows too quickly? It's great if it grows where you want it to.
Mm.
What happens if it doesn't grow where you want it to? If it grows in other places?
In other places, like on the stem?
If it doesn't just grow on farmland?
Oh, okay, yeah. So it might actually disturb the natural selection process where if you have, it's kind of like the same situation with foreign species invasion where
Precisely.
where if you introduce something that doesn't have a predator in nature, it might grow out of control and take over other plants and destroy diversity in a certain area.
Good. And on the flip side, what is the negative aspects of having something that's not going to be quite genetically diverse? It's going to be the opposite. It's going to be very, I'm not going to say the word, but what would be the consequences? Without trying to give the game away.
Sorry, just to clarify, consequences on...
In terms of having reduced genetic diversity, what are the consequences of reduced genetic diversity, particularly with plants?
Naturally, a lot of things grow under symbiotic systems or a proliferating biosystem, really. For instance, the earthworms help plow through the ground so that the plants can place their roots deeper into the ground and get more nutrients, and also other organisms decay to provide the nutrients for the plants. So if that diversity is wiped out and just one single species comes in and grow, eventually the land might become less useful and proliferating, and that might in turn impact the total yield we are trying to increase in the first place.
And what about if I talk to you about, I don't know, some sort of bacteria that could really badly affect, or an insect population that could wipe out that particular plant?
Then that might not only target the genetically edited version of the plant, it might become an entire epidemic for this plant species that would not be introduced if not for genetic editing. Maybe some sort of something we did with the genome led to a selection of this sort of bacteria that not only targets the edited version but also other plants or other versions of the plant, which can be very problematic because if the new species of bacteria that we don't understand a lot about is introduced in the field, we might not have the technology, or it might take a long time before we can respond. And in that time, the food supply is going to suffer.
Great, yeah, exactly. Basically, it's the same lines of monoculture. This is the issue that you have, that if you have very small genetic diversity, that means it's more susceptible to new invading species, and you're not going to have that variation in order to cope. Does that make sense?
Yes.
What I do want to consider actually is thinking about something called the Lulu and Nana case. Have you heard about that?
No, I don't think so.
Okay. So effectively, it was a Chinese scientist that, against the law, was actually
Is it to edit out the gene that will predispose the child to what is the disease? To AIDS, right?
Correct. It was the CCR5 receptor, exactly that. And it was also more than that, because not only was it for that disease, it also ended up making the twins smarter. Actually, that actually affects one of the intelligence genes, effectively. All right.
Right.
What do you think of the ethical consequences of that?
Okay, I can see the media outbursts already.
Yeah, and there was a huge storm about that.
Right. But at the same, this is kind of what we fear in the first place, and why there's so many restrictions concerning genetic editing. If we're dabbling with a field that we do not completely understand yet, and I'm sure the scientists have at least some good intention in the first place to try to edit out the gene that will predispose the child to the HIV virus. But the side effect in reality just promotes discrimination in a lot of sense, because if you try to add now we found a gene that can effectively make it smarter, and if that is a trend, that will only go to certain places and certain people, which effectively will create discrimination in terms of diseases, intelligence distribution, which is not the consequences we want to see. Genetic editing is not available to most of us, and if that is going to be a trend, some of us is going to be naturally more talented because of genetic editing. That is not the way we want to go.
Yeah, good. So you think about access to it. What else? What could be some of the potential positives of HIV removal in terms of genetic editing?
Yes. The obvious consequences or really benefits are huge, so that someone might be very susceptible in the first place, might now have a better response to HIV. And not only that, but we're gaining more experience by doing this experiment, although very illegal. But we now know more about what can potentially happen when we try to edit out a gene related to a congenital disease that might be applied to other fields, that might be used to edit other mutations, maybe not in human, because that's not the ethical thing to do, I think. But that will provide a lot of evidence for, say, experiments on rodents or other species.
Okay, thanks for that. So what I'm going to do is I'm going to actually move on to this diagram here,
Okay.
all right? So this diagram shows you the challenges facing the NHS.
Yes.
So, in this graph, we talk about challenges facing the NHS. So would you be able to describe to me what's going on?
Yes, so the title suggests that this is the amount of people on the waiting list since 2015. So the general trend I can see is that it's always been increasing, but there is a very steep increase after, is it December 2020? But there's a very steep increase after that point.
Yes, exactly that.
And there's a very slight, but actually significant compared to the rate of increase before 2020.
Yeah.
But there's a significant dip before the steep increase.
Yeah. Why do you think there was a dip?
So timing is of the essence here, I think. That dip occurred on December 2020, which, if I remember correctly, is when actually it suggests on the graph that's the start of the pandemic.
Yeah.
What kind of restrictions did we do at the time?
So if we say, it all really started happening in February 2020, in terms of the lockdowns, for example. So why do you think there was a dip?
So I think that's related to what we did at the time. And related to the waiting list, we canceled a lot of procedures at the time, which may actually be beneficial to release some capacity that may not firstly be available to allocate those resources to essential procedures. That might actually cut back the backlog at the time, but very briefly, because then to reallocate all the resources to dealing with the pandemic, and that might mean that eventually the capacity is going to be overwhelmed by the pressure we are having as a consequence of the pandemic and building health problems.
Yeah. So let's just go back to the title. So we're looking at consultant-led elective care. What is elective care, firstly?
So elective care is when a patient is set a date for to do a procedure, usually a surgery. And it's a planned surgery to tackle a long-term problem.
Good. Is it urgent?
I guess the urgency depends on the disease too, but not as urgent as if as non-elective emergency room surgery.
Yes. So it's not as urgent as emergency.
Yeah.
But otherwise, it's kind of hard to say, isn't it? Like if someone's getting really agonizing hip pain and they need a hip replacement, that is kind of urgent, right? So it becomes quite difficult when we think about these operations. But you're right; these are scheduled operations. But the degree to which they're urgent, they're kind of in the middle, aren't they? They can certainly be urgent, that's for sure. And what sort of population do you think? What sort of factors could be influencing this increase that we're seeing? Yes, because of COVID, but unpick this for me. What's going on here?
So even before COVID, the waiting list is steadily increasing. I suppose there's a lot of factors in play, partly because we have an aging population that might lead to more healthcare problems, and we don't have an expanding healthcare system to deal with that.
Just to pause you there. So talk to me about this aging population. What does that mean?
So the general distribution of the age of the population is shifted towards the to the elder side, maybe due to a more excellent healthcare, but at the same time that predisposes a lot of issues and builds up a lot of health concerns for the entire population. Your body tends to have more misfunctions
Yeah.
as you get older. Lots of disease have age-related risks, so the risk of a lot of diseases increases.
If you get one disease, what are you most likely to also get along with one disease?
A treatment.
Another disease,
Another
actually.
disease.
You're very likely, you're gonna get, if you have one disease, the chances are you're actually going to have another as well.
Really?
So they kind of compound.
Okay.
Can you think of an example where that could occur? You take, say, I don't know, diabetes.
Okay, I was actually thinking of something else. But
Okay.
if there's diabetes, you have long-term diabetes.
Yeah.
You will constantly have high level of blood sugar, and that might lead to some sort of coronary artery disease. Because if sugar builds up in your system, eventually it's going to lead to some sort of immune response because it's at a higher level. And
Absolutely.
that might attack other things that it shouldn't attack and build up a plaque that may potentially block the arteries.
Precisely. So then from diabetes, you can have complications in terms of your cardiovascular system, in terms of your neuropathies, in terms of your nerves as well, in terms of your eyesight as well, in terms of your risk for glaucoma.
Oh.
So all of these things increase. Okay, so really good. So thinking, and that name, when you have multiple diseases, it's called a comorbidity.
Okay.
Morbid is in disease, co meaning existing along with.
Right.
So having multiple disease. Very good. What else would you want to consider?
So yeah, I'm aware that there's a staffing issue in the NHS even before the pandemic, that we have a huge gap in nursing that we need. There's still a gap in among the doctors we have versus what we need. So that might add up to the problem that can create a backlog in the first place, and that backlog can have their conditions progress to create to put more pressure on the healthcare system. It's basically a vicious cycle that will keep on increasing the amount of pressure put on the healthcare system, and that can translate to waiting time.
Yeah, absolutely, absolutely. And what are the consequences of someone spending longer on the waiting list?
Well, their condition will generally progress, won't they? So let's take cancer because it's the most obvious consequence.
So we're not going to consider cancer only because it's not necessarily considered elective as such. It'd be done so more in advance and you'd be on the cancer waiting list.
Okay.
So if we treat something, I don't know, like a hip replacement.
Okay.
Talk to me about that.
So hip replacement usually comes after an osteoarthritis, which is the wear and tear of the hip joint, really. And if left unattended, the wear and tear is just going to get worse, and gradually your mobility will drastically decrease, which can lead to other issues like obesity.
Fantastic.
And that's what you were talking about comorbidity.
Exactly.
So that will lead to other healthcare issues which may need another surgery to tackle.
Precisely.
So if you have a coronary artery disease, you might need a stent in your coronary artery.
Good, fantastic. So thinking about the fact that one, the longer that something gets delayed, the actual procedure itself becomes more complicated because it can be more severe. Secondly, thinking about the downstream consequences of more likely to have another disease, which in itself can then complicate the surgery further.
Right.
But also then thinking about it in terms of maybe needing another elective surgery as well. And also on similar lines, hip, if you've got an issue that's not going to be fixed, think about the other joints that are going to be involved. That might mean that you're more likely to have a knee issue as well, because your hip's taking up more of the slack.
Yes.
So those are some really, really good points here to think about. Excellent. So that will conclude my the Oxford interview today. Do you have any questions for me?
No.
Okay. Thank you for your time.
Thank you very much.